Okay, for today, we are doing absolute values of functions and reciprocals of functions. This is a reciprocal. When you do 1 over something, that's a reciprocal of a function. And you have to get good at figuring out what's going to happen to a function when you either take its absolute value, which can be done either on the outside or the inside of the function. Think about that. I think you know outside versus inside of a function does different things. And then this is putting 1 over a function. All right, so go to this slide for just a second. Do you get that this purple one, this is the absolute value function? Okay. And I've showed you this before, that if you take the square root of x squared, it's the absolute value of x. We need you to understand that the square root of x squared is not just x. If it was just x, the line would run like this red line. It would just go like that if it was just x, but it's not. Okay, so that's just a reminder about that. But we're not talking about the absolute value function. We're talking about taking a function and then doing the absolute value of it. Do you get that this is the absolute value around the outside of a function? So let's just talk about when you absolute value something, do you get that that makes it turn out positive? Like if I have the number 8 and I absolute value it, it pretty much makes it positive, right? Absolute value is not like an opposite of thing. Like if I have the number 8 and I absolute value it, I still have 8. If I have the number -8 and I absolute value it, it makes it positive 8. It's like a positive maker. It makes all the results come out positive. Unless you want to argue about 0, because if you have 0 and you take the absolute value, it's still 0. So I guess the lowest it could be is 0. An absolute value could never come out negative. They always come out 0 or a positive number. Okay, so then when you absolute value a function, here's how I want you to picture it. You got this function. Let's make one of those hats like this. If that's my function, sketch this. That's f of x. What I need to teach you is how to do the absolute value of f of x 2 different ways. Would you agree that the inside of a function, I'm going to digress for a moment here. Let's say I had x squared like this, and I go like this, and I put like -1. The inside of the function makes like right and left or horizontal kind of changes, right? So like me putting in a -1 there, that would have moved it which way? To the right. Okay. And if I put like a -8 here, that would move which way? Down. So the stuff in here is horizontal moves on the inside and vertical moves on the outside. So then the reason I bring that up, back to that question we started with, pause for a second, I'll pull that up. So just going back now to that question that I never answered from earlier, how do you move this point? I was reminding you just a second ago that the changes on the inside are horizontal things. So are there changes to the what? To the x. And the stuff that's on the outside, those are vertical changes, so those are changes to the what? To the y. So then you should have changed your x by taking your x, not doing that to it, doing the opposite of that to it. And so you should have taken 0 and added 4 and got a new point of 4, comma, and then you should have taken your 8 and done what to it? Well, it's got a times 2 and it's got a +7. Does it matter what order? Totally does. Because if you add 7 first and then double it, you get this totally different than doubling it and then adding 7. Okay. So what comes first? The multiply by 2 comes first. So we have to times that by 2 makes 16 and add 7, and 16 plus 7 makes 23. How many of you had 4, comma 23? Okay, good. Then you get the basics of how you move a function. That's like the first half of this test. The second half of the test that you have on, at this point, I'm leaning towards Monday after the long weekend. At the second half of the test is about absolute valuing a function, which is totally different than just moving it. All right. So now, going back to that other slide, And if I want to absolute value this guy, there's two ways. I can either absolute value the outside. I just remind you a second ago, when you absolute value the outside of it, that's doing stuff to the what's? The x's or the y's if you're on the outside? The y's. And also, think of it this way. F of x is y, isn't it? If I say f of x, that means y. Just x means x, and f of x means y. So it's like I'm absolute valuing the y's. So think about this. If I'm absolute valuing the y's, that means that any y that is negative should turn positive. The little hat that I made there, if it's where we have it originally, do you get there aren't any negatives on the y's? The y's are never negative. Do you get the absolute value of this function? It just doesn't change it at all. Does that make sense to you? It's kind of like a number that you absolute value that was already positive. If it was positive, like if I said, here's 6, now I absolute value it. It's like, well, it didn't change. This function, when you absolute value the outside, it doesn't change because there's no negative y's. All right, now I'd like you to change it a little bit. I'd like you to take your function and drag your original function down here. And now I ask, what would the absolute value of the function be? All right, so get your function moved. Do you get now it has some points where the y's are negative. And when you absolute value it, it will make those negative y's into positive y's. Just sketch what you think the answer is, and I'll tell you in a moment. Some parts of this function aren't going to change a bit because they were positive numbers in the first place. All right. Do you get that this part right here, all of those numbers in there were 0 or positive, and therefore they weren't going to change a bit? Does that make sense to you? Now, how about the ones that had negatives? Well, they just got absolute valued. They turn into positives, and therefore this part goes like that, and this part reflects up. My new answer is the blue one. The stuff that was negative got reflected up. The black one's gone. Again, the final answer, the black one was the original, so I'm going to get that out of there. There is absolute valuing that. Notice there's nothing in the negatives. Why? Because we absolute valued them and they became positive. Notice that's totally different than reflecting it across the axis, because then you'd have stuff in the negatives still at the end. But when you absolute value something, think about it. If you had any negatives, it would have become positive. So final answer is that blue one. All right, I want to give you another one that's like that. Let's see if you can do absolute value on the outside. It's the easier of the two. Let's say we have a function that goes like that, like a big check mark. Goes through the origin. Would you tell me what it's, if this is f of x, what would be? Don't get distracted. Do this. Otherwise, you're going to fail your test. Sketch that. A blank notability doc out. It's fine. Do you have notability or not? Okay. Then I'm just going to give you a piece of scratch paper the old-fashioned way. There you go. So sketch the red one to start with, and then its absolute value. I'm going to pause for a second while you compare with the kid next to you. Okay. Final answer. This part doesn't need to change, doesn't need to change, doesn't need to change because it was all positive. Now, it was going into negative world, so I'm going to deal with that in a moment. This part also doesn't need to change. So then what needs to change? That just that bottom part, and you go like that. Raise your hand if you had that one right. Okay, good. Okay, I think you get absolute value in the outside of a function. Now let's see about absolute valuing the inside of the function. It'll be different because we aren't going to be absolute valuing the y's. We're going to be absolute valuing the x's. It's not quite as simple as you would think, however. There, I absolute valued the x's. And I know you're thinking, okay, so I just take all the negative x's and like do the same thing I just did a second ago and like reflect it over or something. It's not quite that simple. In fact, I don't even want you to put a theory out there of what you think it looks like. I know a lot of you are going to think, oh, so this part stays the same, which actually you're right about that. That part stays the same because all those x's were positive in the first place. So you get you absolute valuing those x's aren't going to do anything, right? But then people think that somehow this reflects over this part right here. They think that reflects over here somehow, and it does not. Here's why. Well, first thing, it wouldn't be a function anymore. Do you get that? Okay. Second thing, you got to think about how a function works. Let's say that that spot right there is -3. Okay. If I stick in x is -3 into my function, do you get my function instantly absolute values that and turns it into a +3? So it's like I stuck in a +3. What does the function think the answer is then? It goes over here to where +3 is and says, oh, the answer is this. So when you put in a -3, it thinks you put in a +3 and it kicks out that answer, which is like that. Do you get if I put in -1, the function thinks I put in +1, it goes over here, finds this answer, and at -1, it would put in the same answer as if it put in 1. Do you get what's going to happen here? Final answer. It's a reflection across that line of the x portion. Because why again? And I know I get some of you are never going to get this, and that's okay. As long as you get it's a reflection across that line, you're going to get the problem right. But to really understand what's happening, if I put in -5 in my function, I go over here, I put in a -5, what does the function think I put in? 5, because it absolute valued it, and all it sees is a 5, and then it acts like, okay, well, what's the answer when he puts in 5? It goes over here to regular 5 and says, the answer is this. That y value is the answer, this height right here, whatever that is, like 8 or 9 or whatever. And it says, okay, it's like he put in a 5, so we're going to kick out that answer, which goes right here. All right, so process, if you want a really quick reminder, say you got an absolute value of a function, let's say it's like that, and I go, I have f of x, but he wants me to do the absolute value of the inside, then that means this part, all the positive x's aren't going to change a bit. So that all stays the same. And this side, all those get changed, and I get some of you think they should reflect. They will not. And all it is a reflection across this line. So it's kind of like, final answer is that. Check and see if you got it. Let's say, here's my function, and it goes like that. Then what's, this is f of x, what's f of absolute value on the inside? First, I'd start with what stays the same. right, why don't you show your answer to your neighbor and see if they got the same thing as you. Okay, let's see if we can agree on some things here. Would you agree that all of these things have a positive x? Their x is positive for all of those things. So those stay the same, because absolute valuing something that's positive doesn't change it, right? So that part stays the same. This part just goes away. I'm going to erase it. It just goes away. That's the thing that's important to understand here. And then all you got to do is reflect it. And again, if you're asking why should I just reflect it? Because if you pick -1 and you want to put -1 in the function, it's going to think, it never sees what happened. It thinks that you put in +1. And so it's going to go over here and figure out, well, what +1? I should give the answer of that. So then it gives the answer of that. And if you keep doing that with all the points, it will just be a reflection. And there we go. Now, technically, is that a function? No, because it doesn't pass the vertical line test. That doesn't mean you should be like, oh, I got burned, I was wrong. No, it's just you just reflected something that technically was a relation, not a function. I can still call it f of x, but it wasn't a function technically to start with, because it wouldn't have passed right here. It's got more than one answer. Okay, so that's finding the absolute value of the outside of a function and the inside. So let's pull it all together into one question where they give you this sort of a mutated w. All right. First, tell me what's f of x except we absolute value the outside. Draw over it in like a different color. Use a different color or it gets really confusing. Tell me what you think that would be. I like to think of it as you just absolute valued all the y's. So my y's that were positive, they don't change. There, all that doesn't change. And then the y's that were negative just become positive. It's that easy. It was -6, now it's +6. So this part like down here goes up here. So there we go. Raise your hand if you had the green one. Okay, good. Then let's take that same nasty squiggly thing and say, what would it look like if we do absolute value of the inside? Do you want a review of what the answer looked like? Okay, I'll put it back up. The green, hold on. There, the green one there. Okay? All right. Now we're doing the absolute value of the inside. So my advice, find the x's that are positive and make them stay the same. All that stays the same. The x's that were negative, I would just erase them. And then I would do a reflection across that line. Raise your hand if you had that one right. Good, I'm getting almost everybody on every one. We're good on that, and that's good because that's an important part of this unit, and therefore, whenever I say that, I think you can translate that as probably something on the test. In fact, if you're smart about taking notes, since in this class I don't give you a review test right before the test, it would be smart for you every time I say like, oh, that's important, you maybe should put a star by that thing, because that's probably something you could come back to if you're really going to be diligent about studying for your tests. And by the way, some of you have B's in here, but you should have A's. You got to learn how to study for the tests. So when I'm saying things like this, you're not going to remember that on Tuesday of next or Monday of next week. But if you're studying this weekend and you actually could go through and every time I say something seems important and you put a star by it, you can go back and say, oh, I bet I study that. Okay. Now what's an inverse? Well, first of all, that's a totally different kind of thing. If I had the number 8, remember we were absolute valuing a second ago, What does inversing it mean? What does it mean to inverse that? Yes? Good question. That's an inverse. That is not what we're doing today. An inverse of 8 would be negative 8. It'd be just the opposite of it. Okay, but a reciprocal, that's an important difference. A reciprocal is not the opposite of 8. It's not negative 8. What's the reciprocal of 8? Yes? 1 over 8. So if my function looks like this, let's keep it really simple to start with. My function looks like that. What's its reciprocal? How do you put 1 over a picture? No, it's not as simple as reflecting it. This is not a reflection at all. You don't like take this and go flip it down here or something. It's not like that at all. What I'd like to do to show you this, I think this is the best way to do this, is to figure out exactly what each of these points are along the way. And I'll do it as points. And if you see what I'm doing to each point, you'll start to get the idea how to do it as a picture. But just one point at a time. Would you agree that that spot could be 0, 8? And this spot here could be 5, 0. Let's make up a few other points along the way. Let's say this is like 4.8, 1. Let's say that's 3, 4 right there. Let's say that's 1, 7.5. And there. I've got all my points, and then I could connect them later. If I could connect the dots, I could make a curve there, right? This is not going to be a reflection. It's one of the biggest things I got to get you from thinking. But if I want to take this black function, we should call it something, I'm going to call it f of x, and do its reciprocal. Its reciprocal, its new function, let me call it g of x, will be 1 over f of x. Now I want you to think about that for a second. If I do 1 over f of x, do you get that's kind of like 1 over the y? All right. So this point right here, 0, 8. If I take 1 over the y, but the x stays the same, it's going to turn into 0, 1 over the y, so 1/8. I'll do my new graph in blue. This guy, I'll make him blue. So 0, 1/8. Really small. This next one's hard because it's 1 over 7.5. Do you know what I mean? Like, that's going to be a little bit of a pain. How about we do this point right here? We'll get to that other one in a second. It's the point 3, 4. Well, the new point is going to be 3, 1/4. Ooh, that's weird. The next point is 4.8, 1. What's the new point? 4.8, 1 over 1. What's that equal to? 1. That's the only point they will share. And then how about the last point? 5, 0. Ooh, wait a minute. It's going to turn into 5, 1 over 0. And what's that? And therefore it makes a asymptote line. This spot, anytime your function hits 0, you make an asymptote line there. Why? Because it's 5 comma 1 over 0, which is impossible. Now, how do functions act as they get close to an asymptote? This one was going up, and by the way, I can go back and fill in that 1.1 over 7.5 is going to mean, well, a little bit higher than 1 over 8. So I'm putting in a point just kind of to connect my little sequence here. It's going up, up, up. You see how it's going up, up, up? Why? Because the other function's going down, down, down. This function will go up, up, up. Does that make sense to you? When the one goes down, the other goes up. Why? Because it's the inverse. If I have 6 and I do 1 over 6, that gets really small. What if I had like 100 and I do 1 over 100? Where the one function is really big, the other function will be really small. All right, put that phone away. And now I'm going to make this get closer and closer and closer and never touch. There. There's my answer. That blue one is the reciprocal of the original. I'm going to make a new one. You guys all know that function, right? Just plain old-fashioned parabola. What's its not inverse? What's that word called? Reciprocal. Try to make its reciprocal. Hint, one of the best spots you have going is when the function was 0. Because at that moment, when the function is 0, the new function is 1 over 0, and therefore there's an asymptote line right there. So I'll get you started. There's an asymptote line running right here. And now use a different color than black or whatever you used in the first place. Make a new color and try to draw what you think the reciprocal function for this would be. Remember, as the function gets bigger, its reciprocal gets smaller. If you get to like 100, then it's 1 over 100. If you get to like 1,000,000, it's like 1 over 1,000,000. It gets really, really, really small. So as the one gets really big, the other gets really small, and vice versa. Can you handle it? If you can't handle it, honestly, at least put a few points on here and do what I said before. That's the point 1 comma 1. We know that would be on x squared, right? And 2 comma 4, that'd be on x squared. And negative 1, 1, that'd be on x squared. And negative 2 comma 4. And remember, when I do, if this is f of x, then I do 1 over f of x, it's the y's that are getting reciprocaled. All right, I'm going to pause for a second. When you think you got it, show it to somebody near you. Oh, hint. What's the one place where when you do 1 over it, it won't change? Do you get that this spot and this spot, because their y's are 1, and when I do 1 over them, it's going to be the same? Those are the only spots that the graphs will ever cross. The reciprocal will be the same exact thing as the original. All right, give that a try. Okay, here's the theme you have to get straight. First of all, you find where the function touched 0 and you put an asymptote there, because 1 over 0 won't exist. Then you find the spots where it would be equal to it, like these two. Has to be there. And then as the 1 gets smaller, like if I have numbers getting smaller, like 8, 7, 6, 5, etc. As numbers get smaller, when I go 1 over that number, do you get actually they're getting bigger? Let's say as this number gets smaller and smaller, and I put 1 over it, 1 over it, 1 over it, 1 over it, 1/2, 1/3, 1/2 is getting bigger. 1 over 1, that got even bigger. What if I get even smaller? Let's say I get to 1/2. Then I have 1 over 1/2, and it actually turns into 2. Get what I'm saying? As 1 gets smaller and smaller, you're doing 1 over that. So it's getting bigger and bigger. So as the black one gets bigger and bigger, see the black one here getting bigger and bigger? The other one should be getting smaller and smaller. And as the black one here was getting really small, the red one will get really big. I know some of you probably made it go into the negatives, but I want you to think about this. By putting 1 over something, can you ever make it negative? No, you can't. So for those of you that thought, maybe you thought it would go down here, but it can't because you have only positive numbers. How can you put 1 over something and make it negative? You can't. So therefore, your answer is this red line here, and then on the other side, of course, doing the exact same thing. When this gets really small, this gets really big. So it's like that. There you go. 1 over that function looks kind of like that. And if you were to graph 1 over x squared, it is one of the parent functions for you guys. And guess what it looks like, what I just drew. Here's a quick sketch of it. It has an asymptote here, and it has lines that run here and there. That's the parent graph of 1 over x squared. So when you take the inverse of something, what's big becomes small. What's small becomes big. And the only place they'll ever cross is when y is what? 1. All right, so I'll give you one more. No question? Yes? Because there are x values that are on both sides of the dotted line. So like this point right here, its new point is going to become -2 comma 1/4. It's just the y that's getting reciprocaled. All right, so here's a new one. Let's say I had this wave where it's like part of cosine. That's my original. What's the reciprocal? And I'll give you some points on it just so you can tell. Let's say this is where it hits 6 comma 1. And this, let's say it hits that at, I don't know if that's 6, what is that like? Let's say that's at 7 comma 0 right there. And let's say this spot is at like, that's 6, maybe that's -3 comma 0. You can do this point by point if you want to. Keep the x's the same. Take the y's and make them 1 over that. Yes? 0 comma 7, you're right. Thank you. That's what you're going to say, right? Okay. Thank you. I sometimes mix those up. Remember what I said about finding the asymptote lines first? There's pretty much always going to be asymptote lines because we always make the functions hit 0 just to make you figure out, what's 1 over 0? If that's f of x, we are finding 1 over f of x. Notice it's the y's that are actually being messed with. All right, asymptote here. Asymptote here. Now, your assignment for tonight, in the file, you will find there's a whole bunch of problems. They are all due, but not tomorrow. They're due the next day. So hopefully you can get a bunch of them done tonight. The assignment says assignment at the top of it. You'll find it. I will pause for a moment and find it for you. So here's where your assignment starts, just to be clear. And I'm asking you to do all of these, except they're not due until, not tomorrow, but the next day. That's all I got for you for today.